Okay, so on 1.7 we start dealing with what we call absolute value. Does anybody remember what absolute value is? Distance from zero. That's the definition of absolute value, is the distance from zero. Whether I go forward or whether I go backward, I'm still going a distance. So therefore, that's the reason why it's always positive. Okay, so if you think about taking the absolute value of a number, we always get a positive thing. It's because it's the distance from zero, and distances can never be negative. Whether you go forward or backward, it's still the same. So when you're going to see a problem, it's going to have these two bars on there. And the bars, again, are your absolute value symbols. Now, when you've had this in the past, you may or may not have seen this done this way. But a lot of times what your teachers did in the past was they did something like this, where it said x minus 5 equals 7. Because it's saying that x minus 5, that distance from 0 is 7. And then what was the other one? Does anybody remember what the other equation would have looked like? What other number is 7 away from 0? Negative 7. So then they would have wrote x minus 5 equals negative 7. Have you done that before where you had to write two different equations? Yeah, chances are. That's how you set it up, and then you solve for x after that. I'm going to show you something different that I decided to do. It was actually with my college class that I do. And I'm going to preface some of the things by it, but it made it simpler for them. Because at that time I had some older than average students that hadn't done this forever or ever. And so I had to make it simpler for them. Last week we talked about compound inequalities. Remember when we had x in the middle? When we talked about getting everything to one side or the other? If I were to take that same problem, we said it equaled 7 and we said it equaled negative 7, right? So what's the difference with me writing it this way? Do I have the same problem as I just did with the other one? Do I have the two equations? Sure I do. If you cover up one side versus the other, doesn't that say x minus 5 equals 7? That was the first one we wrote on the first slide. And then if I go and cover up this one, x minus 5 equals negative 7. That's what we just did, wasn't it? Now how do you solve for a compound inequality? How do you get the middle all by itself? Add 5. Now on the previous slide, which some of you may have done already because you're trying to jump ahead so fast, some of you might have already had the answer. Negative 7 plus 5 is negative 2. And 7 plus 5 is 12. Do I get the same answer this way as I did the other way? Yes. Now, I showed this to one of my colleagues one time, and they said, yeah, that's great. However, now it looks like you're saying negative 2 equals 12, which I'm not. Okay? I'm not saying that negative 2 equals 12. I'm saying that negative 2 can equal x, and x can equal 12. I'm saying two different things. I'm just writing it only once instead of twice. Does that make sense? Now, the reason why I do it this way, and it's not so much more for the equal sign, but it's when we get the inequality symbol in there that really screws you guys up. Okay, and that's mainly the reason why I do it this way. So if I give you another one like that, 5x minus 10 is equal to 45. How do you guys want me to write it? Do you want me to write it as one equation or one line with two equal signs, or would you rather have it be two separate equations? And to be honest with you, I don't care which way you select. So if you guys want to do it as two separate equations, please do so if that makes more sense to you. Or if you just want to write it down as one line with two equal signs in it, that's fine too. Whichever way is more comfortable to you, please do it that way. So, Taylor, what do you think? 1, as I watched you already write it. So negative 45 equals 5x minus 10 equals positive 45. So, Nancy, what's the first thing then we do after we've done that? Yeah, add 10 to everything. So I got negative 35 equals 5x equals 55. Bridger, how do I finish it out? Divide by 5. And negative 35 divided by 5 is? Negative 7 equals x. And 55 divided by 5 is? 11. And we're done. There we go. Okay. So, as far as that goes, if you want, you could have set that up as two separate equations and got -7 and got 11. That's fine. Or if you want to try this new way where you've got one line down, maybe it looks a little bit faster. Ultimately, weren't we doing, Nacy said adding 10 and then Bridger said dividing by 5? It's either A, you do it once, or B, you do it twice. Whichever way you want, that's up to you. What do you think? Like it? Hate it? That's up to you. Okay? I don't really care which way you choose. Now, the only thing that it doesn't work for, though, is if we get something like this where we've got 2x plus 12 inside and we have 4x on the outside. If you have an x on the outside, it does not work doing it that new way that I showed you. The reason for it is then because you would have x's on all three sides, and where do you move your stuff to? So you're going to have it be two separate equations if you have more than one x in play. Okay? So you're going to have it as two separate equations like we wrote that first slide. So you're going to have 2x plus 12 equals 4x. And 2x plus 12 equals negative 4x. Unfortunately, my little trick does not work if it's got more than one x in it. Okay? So if you have more than one x, you have to set it up as two different ones. So, how do I solve for x on the left-hand side? Tyler, what do I do first? Minus 2x. So what Tyler is doing is he's moving his x's to the right, which really, it doesn't matter which side you move it to, right? But you want to move it just to make it a little bit quicker. Then Brett, how do I finish it out? I divide by 2, and I get 6. Okay. If I do the same process that Tyler and Brett said for the other one, I'm going to get the same type of scenario where I'm going to subtract 2x to both sides. But this time I'm not going to get 2 there, I'm going to get negative 6. And divide by that, and I get negative 2. Now the trick to this is that it's going to also ask you to check for extraneous solutions. What that means is some of those answers that you get, you have an answer, but it won't work. Remember, initially it was the absolute value of something equals 4x. We already talked about this before. Can absolute value be equal to a negative? No, because it's the distance from 0. So if I put negative 2 back into the original equation, on the right-hand side, I have 4 times negative 2. So I would say the absolute value of something equals negative 8. Is that an issue? Can you have negative on the outside? No. So guess what this does? You got to throw it away. This whole thing, even though we solved for it, we did a great job getting negative 2, doesn't work. What if they both don't work? What if I had to throw both of them away? Then it doesn't work. Then you'd have no solution. Okay, so if they both don't work, we have no solution. But that one does not, because we can't have negative 8 on the outside. Okay? Now, the real reason why I started going with the whole one thing as compared to 2 was for this type of scenario, is when I had my greater than, my less than, my greater than or equal to, or less than or equal to. So, back in your freshman, sophomore days, when you guys had this Algebra 1 stuff, when you guys had to write 2 different equations, here's what I couldn't get through to my college people. 4x plus 5 is greater than 13, which you guys usually get that one just fine. But then you'd have 4x plus 5 is less than negative 13. Do you understand, or do you have an idea as far as what normally people would screw up on that problem would be? The changing of the symbol, right? This part right here is the main culprit for why people would get this wrong. They would keep it the same direction, they would forget to switch it, and then all of a sudden, it's wrong. The whole thing would be wrong, or just that one side would be wrong. So, watch what I do here. If I go 4x plus 5 is greater than 13, now just like a compound inequality, if I go the same direction, I want to point out the fact that my arrows are pointing the same exact way. And I put negative 13 on the outside. Is that the same as me writing what I did as two different equations? So let me cover this up. Is 4x plus 5 greater than 13 on one of those two? Yeah, it's this one. Then if I cover up this side, negative 13 is greater than 4x plus 5. Notice how it's going to open up and eat the negative 13. Isn't it going to open up and eat the negative 13 here? Do you have to remember that you have to switch the signs or symbols when I do it this way? No, you don't have to think. All you got to do is say, hey, it's got to go the same direction both times. This always works. I've done them for 15 years that way. I've decided to start doing it that way. I've never seen a book do it that way. Ever. But after doing as many of them as I have, this has never not worked. It makes it simpler. It's less thinking. Now you do a compound inequality a lot faster than having two. Because like I said on the original part where I circled it in green, most people forget to flip that symbol. And if you forget to flip the symbol, it's wrong. No thinking involved. So now I'd subtract 5 to everything. So I get negative 18, 4x, 8. By the way, if I multiply or divide when there's an inequality symbol, do I still flip the symbols? If I multiply or divide by a negative, did I say negative? Okay, my fault. I misspoke. If I multiply or divide by a negative, do I still flip the symbols? Yes. Regardless if it's like this or if it's like another one. Now, on that one stuff that's on the left there, negative 18 over 4 does not come out evenly. And that's the problem that somebody had this morning is that they were asking, how do I graph fractions? It's the same as the other stuff. So in this case, 18 fourths is the same as negative 9 halves or 4 and a half. Yeah. That's a 2. Looks bad though. But negative 4 and a half, you go halfway between negative 4 and negative 5. You try to make the dot in there somewhat close to that. Because if we're at negative 4 halves, or 4 and a half, we're back in between negative 4 and negative 5. You put one in the middle somewhere. You're not going to sit there and take a ruler out and measure exactly halfway. I get that. So try to make it close to where it is in the middle between them.
Can you make it into a decimal?
Sure, absolutely. If you want to make it into, and that was the question that they had this morning too, was, is that okay if I make it like, I think it was 3 halves and they made it 1.5? And yes, absolutely. If that makes it easier for you. And honestly, to graph something, decimals is way easier than a fraction. But yeah. All right. So, just so that you guys are aware of it, as far as anything else, that's about it. But I want to give you one more just so that you guys can see this in action one more time. So how would this get written out if I want to do it as one as compared to two different ones? What goes in the middle? And then 10 on the right, and negative 10 on the left. Now remember, notice my signs, I didn't change them, did I? They're the same direction. Now what? Subtract 6. So I got negative 16 is greater than or equal to 2x, which is greater than or equal to 4. Now what? Divide by 2. And I get negative 8 is less than or it's greater than or equal to x, which is greater than or equal to 2. And I'm done. Do you like that way? I guarantee you, you'll never see that in another book. I have never seen that. But guess what? It works every time. And I came up with that because I had some students that were older than average that always forgot to change that symbol. So I had to come up with something that worked for them And this does. It's never not worked. As far as graphing it goes, I still graph it the same way. I'm going to put -8 on the left, 2 on the right, close circles, and then I either shade out or I'd shade in between, depending on whatever it tells us to do. In this case, it would shade higher and lower. Okay, if I were to graph it. Now, there is a couple other ones that we need to talk about, too, just so that you guys, I almost forgot about this. What if I would have had 3x plus 5 is equal to -2? Is that a possibility? Can you have it be equal to a negative? No. If they give you a problem like that, where they say equal to a negative on the outside like that, stop. Don't do it. Just put no solution and move on. You do not need to do this. Most people then go, well, yeah, it can equal -2 because you did it on the other side. No. When it's the absolute value setup, you cannot have it equal to a negative. So therefore, not going to happen. Same thing goes for if I were to have 3x plus 5 on here, and I said less than 0. Think about the absolute value stuff and on a number line. Brett told us at the beginning it's the distance from 0, and he was correct. If a number is less than 0, how can it be the distance from 0 if it's less than 0? What numbers are smaller than 0? Negatives. Can a negative be in that situation? Can you have that then? No. So guess what? This goes away. It's no solution. What if it were to say negative, or what if it were to have blah, blah, blah is less than a negative? Can you do that? No, you can't. So in that particular case, if it were to say the absolute value of something is less than a negative, you don't even have to do it. You can just put no solution and move on, because a number that's absolute value, or the distance from 0, cannot be smaller than 0. Can't be a negative. So be careful with that. As far as falling into that trap, I don't think there's too many of those anyway, but in case there was, now we have her down. All right? Any questions about how to solve them? You guys want to see another one, or are you guys okay? Think we're okay? All right. So as far as that goes, we have, come on, open up, there we go. Page 55 to 57. Oh, I didn't even give you that part. It can't be 10. 12. Equals 4. So again, just because Alyssa multiples of 4 means, what number do you start with? No. 12. And then what's the next one? Yay. And the next one? No, one more. One more. What's the next one? Don't know? You don't know what the next one is after 16? 20. Yay. Okay. So 12, 16, 20, and so on. Don't forget it's multiples of 4. Stop.